Hi everyone, this is Mr. Kong and this is the chemistry revision series. We are on electrolysis and this is the third part of this whole chapter. If this is the first time you are looking at this video, you may want to look at the earlier videos to have a background of what electrolysis is, as well as the electrolysis of molten and aqueous electrolytes. Now, today we will look at electrolysis involving reactive electrodes as well as some applications of electrolysis. And to recap, what we've done in the past will be to look at inert electrodes and as well as reactive electrodes. And for inert electrodes, we have looked at how electrolytes can either be molten or aqueous, and for aqueous electrolytes, they can also either be dilute or concentrated. Now, for the various scenarios, the products might be slightly different. And now we're going to look at reactive electrodes. And generally, for reactive electrodes, the electrolytes are always aqueous. But regardless of whether they are molten or aqueous or whether the electrodes are inert or reactive, four things are always the same thing. We always need to determine the product at the cathode as well as at the anode, the product at the end, and the color changes, if any, in the electrolyte. So the very first one that we have is our aqueous electrolyte with reactive electrodes. And again, we need to consider that apart from the ions from the electrolyte, there is also ions from water. And again, to recap, this water will produce two ions, the H plus and the OH minus ions. And regardless again, okay, of whether what ions are present, remember that cations are always attracted to the cathode, and at the cathode, reduction has to occur, and the opposite happens for the anode, where anions are attracted there, and oxidation occurs at the anode. So this is really the background, and you realize that in electrolysis, it is consistent with regard to the reactions at the cathode as well as at the anode. Now, one example here will be aqueous sodium chloride with copper electrodes. Now, in this case, the copper electrodes will be considered to be reactive, and I'll go on to explain why. The ions present, same as before, we have Na plus as well as Cl minus from sodium chloride and H plus and OH minus from water itself. And at the cathode, instead of Na plus or H plus being discharged, we actually have Cu2 plus that will be discharged as copper atoms on the cathode. Now, I'll explain a little while where this Cu2 plus came from, but the half equation is shown there in red. And at the anode, what happens is because we are using copper electrodes, the copper anode actually undergoes oxidation to form Cu2 plus. Now remember that oxidation is a process in which electrons are being donated. Now the reason why this copper anode is undergoing oxidation is because it requires the least amount of energy compared to the other two anions, Cl minus and OH minus, having to be discharged. So in this case, it is a very special reaction where the copper electrode is easier to undergo oxidation, and therefore we say that because this copper anode is undergoing reaction, it is considered to be a reactive electrode. And over time, what happens is your cathode increases in mass because your copper atoms are deposited on the cathode, and on the anode, it actually becomes smaller, it decreases in mass over time. Now, moving on, okay, in the electrolyte, there is really no change in the electrolyte because the copper ions came from the copper anode itself. And in this case, the only change is in the form of the electrodes having a change in the sizes. Now, the next example here will be copper sulfate with copper electrodes. And again, it is a very similar situation in which the ions present will determine what is going to be discharged. And at the cathode, again, Cu2 plus will be discharged as copper atoms. And at the anode, the copper anode will oxidize to form the Cu2 plus. And again, there is an increase in mass in the cathode and a decrease in mass in the anode. And same thing, there is no change in electrolyte and only the electrodes have a change in the size.